Welcome to the deep dive. Today we're diving into something, well, truly colossal. We're talking about when stars collide.
Right. Big stuff.
Yeah, but maybe not like you'd imagine, like a head-on car crash in space.
No, not quite.
Yeah.
Especially when we're talking about things like neutron stars, super dense.
Okay, so neutron stars often in pairs, right? Binary system.
Exactly. They orbit each other, getting closer and closer. It's less a crash, more a spiral, a merger.
A cosmic dance ending in fireworks. Huge fireworks.
Unbelievably energetic fireworks. The gravitational forces involved are just immense. Hard to even wrap your head around.
And this isn't just theory anymore, is it? We've actually seen this happen.
We have. 2017 was the big one, GW 170817. First confirmed neutron star merger.
What was so revolutionary about that one?
It was the way we detected it, not just light, through telescopes.
Right.
We also felt it, literally. Ripples in space-time.
Gravitational waves.
Gravitational waves. So we had light and gravity telling us the same story.
Wow. Multi-messenger astronomy, they call it. Like using two different senses.
Precisely. It gives you a much richer picture of what's actually going on.
And what did happen after that merger? The aftermath?
Well, first off, a massive explosion called a kilonova. Way brighter than a standard nova.
Okay, kilonova. Got it.
And this is where it gets really interesting, I think, for everyday life.
Oh, so?
These mergers, these kilonovas, they're cosmic forges. They create heavy elements.
Heavy elements like
gold, platinum, the really heavy stuff on the periodic table.
Wait, so you're saying the gold in, like, jewelry?
A significant chunk of it, yeah. It was likely forged in ancient neutron star collisions billions of years ago, then scattered through space to eventually become part of Earth.
That's incredible. So my wedding ring has bits of a neutron star collision in it.
It's very likely. Makes you look at it differently, doesn't it?
It really does. So gold, platinum, what else comes out of these mergers?
You also get these incredibly powerful short gamma ray bursts, intense beams of high-energy radiation.
Okay. Dangerous stuff.
Potentially, yeah. And of course, the gravitational waves themselves, those ripples spreading out across the cosmos.
So it's this whole package. Explosion, heavy elements, gamma rays, space-time ripples. Immense power.
Absolutely. Fundamental shifts in the universe happening right there.
Now, it all sounds incredibly far away. But is it always far away? Could something like this actually, pose a threat to Earth?
It's a fair question. Space is vast, which is good for us, gives us a buffer.
Right.
But these events aren't infinitely distant. If a merger, or even a different kind of stellar explosion like a supernova, happened too close.
How close is too close?
The rough estimate is within about 30 light years. If something went off that close.
What would happen? Severe consequences sounds a bit vague.
Okay, think about this. The radiation could potentially strip away our ozone layer.
Or planetary sunscreen.
Exactly. Gone or singularly damaged. That would let in a flood of harmful UV radiation.
Which would be catastrophic for life. Mass extinction level stuff.
It certainly could trigger one, yes. And it might also mess with Earth's magnetic field.
Our other shield.
Right. Leaving us even more vulnerable to cosmic rays. So, yeah. Multiple potential problems.
That's sobering. And you mentioned this isn't just speculation. There's evidence this might have happened before.
There's a hypothesis, yeah. Some research suggests a relatively nearby supernova might have played a role in the Ordovician extinction event.
When was that?
About 450 million years ago.
Yeah.
It's still debated, but the idea is that a cosmic event could have contributed. It shows these things can impact Earth, even from further away than 30 light years.
Wow. Okay. And what about stars we know about now, like Betelgeuse? There's a lot of talk about it maybe going supernova soon.
Betelgeuse, yeah. It's a red supergiant, relatively close.
Yeah.
About 700 light years away, give or take.
So much further than that 30 light year danger zone.
Much further. So we wouldn't get that immediate devastating radiation bath. But it is expected to go supernova sometime in the next, say, 100,000 years. Could be tomorrow, could be millennia. And even from 700 light years, if the initial gamma ray burst was really powerful, and if it happened to be pointed right at us,
it could still affect us.
It could potentially impact our upper atmosphere pretty quickly.
Yeah.
So distance helps, but the initial blast is something to consider.
Right. That initial flash is key, which makes detecting these things early seem pretty important.
Definitely.
And our ability to detect them has massively improved, hasn't it, with gravitational waves?
Oh, absolutely. It's a revolution in astronomy. Detectors like LIGO and Virgo. They're incredible.
How do they work, basically?
They use lasers and mirrors over very long distances to measure tiny, tiny stretches and squeezes in space-time itself the gravitational waves passing through Earth.
So we're not seeing light, we're feeling the vibration of space.
That's a great way to put it. It's like adding a whole new sense to how we observe the universe, hearing the cosmos, in a way.
What can we learn from hearing these waves that we couldn't learn from light?
All sorts of things. We can get a new independent measure of how fast the universe is expanding.
The Hubble constant stuff.
Exactly. We can probe matter under conditions that are impossible to create on Earth, like inside a neutron star. Extreme densities.
Okay.
And like we saw with GW 170-817, we can pinpoint where heavy elements are being made. It connects the dots.
It feels like we've unlocked a new layer of reality.
In many ways, we have. It's leading to discoveries we couldn't have made otherwise. Like, remember that black hole merger in 2020?
Vaguely. GW 190521.
That's the one. It was two black holes merging to form something unexpected. An intermediate mass black hole.
Which is significant because...
Because we had good evidence for small stellar mass black holes and supermassive ones at the centers of galaxies. But finding these middleweights was tricky. This observation nailed one.
So gravitational waves are confirming theories and finding new things.
Exactly. Pushing the frontiers. The amount of information packed into those waves is just phenomenal.
Okay, so we know these cosmic collisions happen. We're getting better at seeing them coming, potentially. And we know they could, theoretically, be bad news if close enough. Which leads to the kind of sci-fi question. If we saw one coming, a really bad one, what could humanity even do?
Right. It does veer into science fiction territory, but scientists and engineers do think about these extreme scenarios.
Like what? Hiding?
Sort of. One idea is deep underground shelters. Really deep. Possibly with magnetic shielding to deflect radiation.
Wow, that's ambitious.
Hugely ambitious. Massive engineering challenge. Massive resources needed. Another idea is better early warning satellites, specifically looking for gamma ray bursts to give us maybe a few hours or days notice.
Okay, detection in bunkers. Any other grander schemes?
Well, then you get into the really long-term, almost philosophical ideas. Terraforming Mars or the moon, creating a second home for humanity.
Spreading our eggs into multiple baskets.
Exactly. Or even digitally archiving human knowledge, all of it, onto hardened probes and launching them into deep space. A sort of message in a bottle, a backup.
A civilizational backup plan.
And the ultimate version of that, I suppose, is full-blown space colonization. Becoming a multi-planetary species as long-term insurance against any single-planet catastrophe, cosmic or otherwise.
It's fascinating to think about these potential futures, even if they seem far off. It highlights the scale of the universe and maybe our own fragility.
It does, but let's also flip the perspective for a moment.
Okay.
We've talked a lot about destruction, but these collisions, they aren't just destroyers, are they?
Ah, right. The creation aspect. The gold and platinum.
Exactly. They are fundamental creators in the cosmos. They enrich the universe.
And it's not just the super heavy stuff, is it? The elements of life itself.
That's more from earlier generations of regular stars dying, yes.
The supernovae.
Mainly. Carbon, nitrogen, oxygen. The things we're made of.
Forged in stars, scattered through space.
Right. So the elements making up you, me, the Earth, everything, they came from dying stars. We are quite literally made of star stuff, as Carl Sagan famously said.
It's a powerful thought. That destruction leads to creation.
It's a fundamental cycle in the universe.
Yeah.
The death throes of stars, whether through supernovae or these violent mergers, provide the raw materials for the next generation of stars, planets, maybe even life.
A cosmic ecosystem of birth, death, and renewal.
Precisely. Destruction enables transformation.
So, wrapping up this deep dive, it leaves us with some big questions, doesn't it, for our listeners to think about?
It really does.
Like, how likely do you think it is that some major cosmic event impacts Earth in our lifetime? Is it something we should actively worry about?
And where should we put our efforts? Gilding shields here on Earth, or looking for escape routes off-planet? The balance between defense and, well, running away.
Yeah, that defense versus escape question is huge. And finally, thinking about how we're made of star stuff. What kind of new things, new transformations might future star collisions create? What's the universe cooking up next?
Unimaginable possibilities, probably.
Yeah.
It's a lot to chew on.
Definitely. These events remind us how connected we are to the cosmos, how dynamic it all is.
And perhaps how lucky we are to be here on this relatively quiet little planet for now. It underscores both our fragility and our resilience, I think.
Well, thanks for joining us on this cosmic journey. We hope you'll keep pondering these questions.
The universe certainly isn't short on wonders or mysteries.
Indeed. Until next time, keep looking up.